And we're going to end our lecture with a couple of case studies of some very high performance structures. Often when we look at very high performance, we tend to look at a very modern look. So I wanted to include this. It is a much more traditional looking building. It's actually an old schoolhouse, the Taft Schoolhouse, that has been converted to a residence. And this particular building is Energy Star certified. It has LEED for Homes Platinum, which is the highest level. It's also a passive house, um, WaterSense certified, Zero Energy Ready Home certified, meaning it can create as much electricity and power as it needs in a year. And the windows that were chosen for this project to replace the existing are from this company, clearwall.com, which there's a link outside of this lecture as well if you want to look more about it. They have a movie. They have a lot of good case studies at Clearwall. Um, the windows are from a line called Clearwall Passive Future Proof, and they are specifically engineered to make ultra low energy windows generally accessible to all. The future proof range provides U values as low as 0.341, which is quite low, and that is the equivalent of 7.5 R value. So again, keep in mind that windows are fabulous, but in terms of energy, windows are a leaky part of our building envelope. When we're looking at our walls being R21 or higher, and our most efficient windows being R7.5. The next example is the Karuna House, which is also a passive house designed by Hammer and Hand. We've looked at it in the chapter, but we also have looked at it for the wall assembly. Hammer and Hand is a Portland company, and it's always nice to look at examples that are local. From their website, I'm going to read about some of the things about the Karuna House. Windows make the Karuna House. They are central to the home's aesthetics, its HVAC system, its wall assembly, its airtightness, its comfort, and its energy performance. In high-performance green buildings like Passive House and Minergy P, it's difficult to overstate the importance of fenestration. Now that's a fancy word for windows. Fenestration. Partly that's because windows and doors represent big holes poked through a meticulously engineered and constructed wall assembly, opening potential weak points in the system for the transfer of heat, air, and moisture. So you've got to execute high performance installation of your high performance windows in a project like Karuna. And on their website, the Karuna Wall Assembly page, there's a video about the actual installation process if you want to read about that. No leaks were allowed in the hull of this ship, but equally important is the opportunity that high performance windows offer. They list three, and I'll read through them. Opportunity 1, energy performance. Windows at this green home building project are triple glazed. They have high solar heat gain, R8 windows made by OptiWin in Austria. These windows have a very thin frame, the weakest part, thermically speaking, of a window, so that the whole frame can be over-insulated and fully embedded into the wall assembly. While it's true that even at R8, the windows are several times less insulative than the surrounding super-insulated wall, they are net positive in energy performance because they capture so much solar gain. And in a very low energy load building like Corona, energy performance gains like these can make a big difference. It's not just a drop in the bucket. High performance windows are not some newfangled luxury item either. Triple glazed windows have been standard in Scandinavia since the 1970s and now are code in Germany. More and more high performance window options are becoming available in the US, a welcome development among designers and builders of high performance buildings. The same is true of high-performance doors. The exterior doors at Coruna are also opt-to-win, with the exception of a cellar door that Hammer and Hand built. These doors look a bit like vault doors. They are thick with insulation, gasketed and airtight, and equipped with multi-point locking mechanisms to ensure a tight seal. Opportunity 2 are the aesthetics. High-quality windows open design options for an architect, allowing high-performance projects to break out of the shoebox mold and become a medium for high design, as ripe with possibility as anything else out there. Holst Architecture's design of Coruna, and Holst is also a Portland-based firm. Holst Architecture's design of Coruna is proof positive. Because high-performance windows can be so good at capturing solar heat gain, shading becomes important, especially in the shoulder seasons when sun angles bring lots of rays into the home, but outdoor temperatures are still mild. On modernist homes, with their clean lines free of traditional shade-providing overhangs, the potential for overheating is more acute. Exterior shade systems like the one at Coruna make modernism in a passive house feasible without sacrificing comfort, which is opportunity number 3, comfort. One of the biggest benefits of a high-performance window is its warm interior surface. A conventional window, by contrast, has a very cold interior surface in the winter, setting up an uncomfortable convection current as inside air cools and falls along the window interior, then warms and rises, only to be cooled again. The constant draft this creates can render unlivable big areas of the house near conventional windows. The human body is extremely sensitive gauge of heat and cold, so this convection can be very unpleasant. Thermostat settings creep up. A typical house might be set as high as 74 degrees. But in a high-performance house with high-performance windows like Coruna, a thermostat setting of 68 degrees can deliver comparable thermal comfort. Remember that THAR, right? Making the spaces immediately adjacent the windows cozy and draft-free. And that ends our conversation about windows. Thanks, and I'll see you next time.